important. All right, today we're looking at combinations. Combinations is an arrangement for selection of objects where order is not important. Okay? So basically, we want to think of things as we're going to be grouping stuff together. Okay? Think of it as grouping. Examples of things that we like to group together. We like to group together some committees. Because if you're creating a committee, it doesn't matter, if you take person A and person B. If you would have selected person B and then person A, those are still the same two people in the committee. Another type of thing is, we're putting toppings on something. Now, occasionally it is important to make sure you put things in order, but generally if you're just putting a bunch of toppings on like a pizza, most of the time you're just going to throw them all on the pizza and stick it in the oven. They all cook together anyway. Okay? Examples of combinations. Have our combinations, we say the number of combinations in distinct objects taken R times, okay, R at a time. We write that using a big old capital C with a little n here and a little r here. And what this really, all we're really doing here is, there's a couple of different formulas for it. This one formula here says the doing a factorial, n factorial, divided by n minus r factorial times r factorial. Or you could also think about this as basically I'm doing a permutation of nr divided by r factorial. Those are the same types of things here. And the reason we have to divide with these things is because we have to go back and take out all the things that have been repeated. Like say, I have the letters T, A, K, E, take. How many ways can I choose 3 of these? Well, I could do T-A-K, T-A-K, oh, I already did T-A-K, you don't want to do it twice, that's really great. T-A-E, then I could do T-K-E, T-K-A, I could do, then what? A-T-K, A-T-E, A-K-T, A-K-E. Let's see, what else we got here? Then we got K's, right? So K, A-T, K-T-A, K-A-E, K-A-T. Oh, we've got to put an E second here, didn't we? So we got T-E, K. Oh, we already did cat. Man, cat keeps jumping up there. Man. I gotta watch these things. It's a K. Oh, gotta keep track. That's a lot of these things we gotta keep track of, isn't there? Let's see. We got T-E-K, T-E-A. Over here we got A-E-T, A-E-K. We got K-E-K, T-E-K-E-A, K-E-T. Now we gotta stick the E in front. E-T-A, E-T-K, E-A-T, E-A-K, E-K-A, E-K-K-T. Should be 24 of them, I do believe. Let's see here. Yeah, looks like 24 of them. Now that would be all of our permutations. This order was important, but now order is not important. Since order is not important, I got to go back and see. I got everything that has an ETA. I got ETA here. Anything else have an E, a T, and an A? Well, that one does. E, T, and A. ETA, that one has an E, T, and A. E, T, and A, that one does. Oh, wait a minute, that one does. Oh, let's see, E, a T, and an A, okay? Next, I'm looking for E, T, and K. For the E, T, oh, that one's gone. This one's gone. E, T, and K. This one's gone, and this one's gone. Now, E, A, T. Oh, wait a minute, that's the same as ETA. That one should be gone, too. Oh, look, Eek. Wow, you know, these things get sneaky when you're trying to keep track of them. E, A, K. E, A, and K. So, E, A, that's the same thing. That's the same thing. That's the same thing. That's the same thing. Oh, this one's the same thing, too. Oh, this one's the same as ETK. So we're done with all the E's in the front, all the E's there. Notice there are nothing else with E's left. Next I got TAK. So oh, that one's the same. This one's the same. This one's the same. This one's the same. That one's the same. Wow. There's only 4 things, isn't there? So basically what this is saying, I had 4 things, and I'm taking 3 of them. So my permutation would be 4 times 3 divided by 3 factorial. So 4 times 3 times 2 divided by 3 factorial. Well, remember, 3 factorial is really, so I'm going to have 4, 3, 2 on top. On bottom, I'll have 3, 2, 1. Notice here, 3 and 3 cancel, 2 and 2 cancel, so I'm left with 4. So I should have 4 of them. I have 4 of them left. So let's look at our examples here that we have to work out. Our first one here is just a straight number. It says 10C6. So we're going to write it out longhand here, 10C6. So I'm going to start up here at the top. I'm going to have 10 times 9 times 8 times 7. I'm going to do all the way 6 pieces. So I've got 4. There's 6 of them. 10, 9, 8, 7, 6, 5. That's 6 things. And on the bottom, I'm doing 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. Everything in my denominator is going to cancel out with something on the top. Looking at this right here, 6 and 6 cancel out. 5 and 5 cancel. 4 times 2 makes 8. And 3 goes into 9, leaving 3. So all that's left to multiply is 10 times 3 times 7, which is 210. So if I have 10 items and I'm going to pick 6 of them, how many ways can I pick those 6 items? When order is not important, there are 210 ways. Now, most of these things are going to be set up in word problems, not just from items like this. It says a group of 7 students are working on a project and needs to choose 2 from the group to present the report to class. So essentially what we're doing is I have 7. I'm going to do a combination with 2 of them. That means I'm going to do 7 times 6 divided by 2 times 1. Well, hey, 2 goes into 6, nice and pretty, so I can cross that out and put a 3. So I now see that 3 times 7 gives me 21 ways to pick my presenters. Looking at problem number 3. You can order a hamburger with cheese, onion, pickle, relish, mustard, lettuce, tomato, or mayonnaise. How many different hamburgers could you build if you can only choose 4 toppings? So I gotta first see how many toppings do I have. So I have 1, 2, 3, 4, 5, 6, 7, 8 toppings. I have 8 toppings. I'm going to do a combination, so it doesn't matter which order I put the toppings. I'm going to pick 4 of them. So I'm going to do 8 times 7 times 6 times 5 on top, because I'm taking 4 things, starting with 8 in the first spot, going down to 5. I'm going to divide that by 4 times 3 times 2 times 1, which that's 4 factorial. I go through and now do some eliminating, so I can do these 2, take out my 8. My 3 takes out this, leaving a 2. So I got to do 7 times 2 times 5. Well, 2 times 5 is 10, and times 7 is 70. There are 70 different ways I can build a hamburger, choosing 4 of those toppings. All right, so moving on, looking at our next example here. Now, this example has a couple of parts to it. Okay. In how many ways can a committee of 6 be chosen from 5 teachers and 4 students? So we got 2 parts. I got part A and part B. Part A says that they're all equally eligible. So I have a total of 9 people to pick from. And I'm picking a committee, so therefore if I'm picking a committee, order is not important, and I need to pick 6 of these things. So since I'm picking 6 of them, on top I'm going to start with 9, and I'm going to count down till I have 6 items up here. So there's 1, 2, 3, 4, 5, 6 positions to pick from. But I have to go back and divide now to take out all the things that can be duplicated. So that's when I do 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. I can go and do some canceling now to get rid of some of these things. If you have the same thing on top and bottom, mark those off. So I got 6 and 6, 5 and 5, and 4 and 4. Here, 3 goes into 9, leaving a 3, and 2 goes into 8, leaving a 4. So what I'm left with is 3 times 4 times 7. 3 times 4 times 7 is 84 different ways to pick my committee. If everybody is eligible and you can have equal chances. We could have a committee with 4 students and 2 teachers, or we could have 5 teachers and 1 student. Everybody has an equal chance. Now our next one over here though says that my committee must contain 3 teachers and 3 students. This one has some restrictions. So I'm going to be doing 2 different combinations, and I have to put those together. So my first combination says, hey, I've got 5 teachers, and I want to go pick 3 of those. And I'm going to multiply that by, I have 4 students, and I need to go pick 3 of those. Well, the one for the teachers, that gives me 5 times 4 times 3 divided by 3 times 2 times 1 times, now the one for the students, 4 times 3 times 2 divided by 3 times 2 times 1. Now before I go do any multiplying and stuff, I want to go and cancel anything out that might be, oh, I got a 3 here and here, and I can take this out, making this 2. On this one over here, I can take the 3's out and the 2's out. So I'm left with 5 times 2 is 10 times, the only thing left over here is 4. So 10 times 4 is 40. I have 40 different ways to pick these committees. And our last example that we have for today. Your Algebra 2 class has 3 seniors, 10 juniors, 22 sophomores, and 2 freshmen. If you need to form a class of a class committee of 4 members, how many different ways can you form the committee? Well, first I got to figure out how many people I have in the class. Well, I've got 3, 10, 22, and 2. So I've got to add all those together. So let's see, what do we have here? So I've got to do 3 plus 10 plus 22 plus 2 to find out how many students I have. And that gives me 37 students. So I've got 37 items to pick from, and I'm going to go pick 4 of them. So that means I'm going to do 37 times 36 times 35 times 34 divided by 4 times 3 times 2 times 1. Here I can go and cancel some things out here. 4 goes into 36, leaving 9. 3 goes into 9, leaving 3, so that's even a little better. 2 goes in here, leaving 17. So I am left with 37 times 3 times 35 times 17. And at this point, we grab ourselves a nice handy-dandy calculator. And we punch these things into our calculator. Turn it on first. So I do 37 times 3 times 35 times 17. And I hit enter. So there are 66,045 ways to pick my committee. The main thing to remember is to remember that combinations, order is not important. Since order is not important, cat is the same thing as tack. We would only count that as one item, because those are the same thing. So remember, permutations, order is important. Combinations, order is not important. As always, pay attention to what you're doing, and good luck.